Section 5.2 goes into quite a bit of new information and new concepts. So what I'm going to do is I'm going to go through just a couple at a time and then clear the screen and start over. So if you see on the completed notes, I have it broken down in the 68, 95, 99.7 rule, standard scores, and percentiles. That's going to be how I go through the material as well. So I'm going to start off by talking about the 68, 95, 99.7 rule. Remember, whenever we're talking about a normal distribution, all of the area under the curve is 100%. So let me go ahead and sketch this out. So let's say we have some curve. And we know that the entire area under the curve is 100%. And remember that the entire shape is being generalized from a histogram. So if we were to draw our different classes in here, and I could keep going and keep going and keep going, but if we were to draw all those in here, we're going to have all of our combined frequencies. Let me go the block here. So we're going to have all of the combined frequencies over here. And as we add them up, we're talking about the cumulative frequency to that point. Right? So right in the middle of the curve, we're assuming that that would be half of our data. And so that is 50% of our data. Or in decimal form, we could say 0.500. That is out of 1 or out of 100%. And so we can start to break it down in other ways as well. We could say, well, what if instead of breaking it down in 50% on one side and 50% on the other, what if we had a way that we could use the mean of the data set and the standard deviation to figure out other percentages of our data? So for example, or to elaborate, what we can do is we can say that most of our data is going to lie, if that middle part is our mean, most of our data, or about 68% of it, is going to be within one standard deviation. So if our middle value is the mean, one standard deviation to the left is going to be the mean minus a standard deviation. And then one standard deviation to the right would be plus one standard deviation. So we're doing plus one SD for standard deviation. So now we've seen the data broken up in 50% pieces. We've seen it where we have within one standard deviation, we have 68% of our data. We can go further too. So let me go ahead and erase some of this on our bigger graph. I'm going to use a different color here just to help visualize it. What if we went 2 standard deviations out in each direction? So if this was -1 standard deviation, going one more to the left would be -2 standard deviations. And remember, we're taking the mean value minus a standard deviation, or -2. So that's talking about the mean to 2 standard deviations to the left, And we could do the same to include the 2 standard deviations to the right. So now I'm over here, and this is the mean plus 2 standard deviations. As we can see, that is more than what we had before, was just a 68%, but it's not quite 100% of our data because we still have remaining pieces over here. So we're close, but not quite 100%. We actually end up having 95% of our data lying 2 standard deviations away from the mean. And then we can go another standard deviation out. So we could also have, let me erase this again. I'm going to actually just go ahead and erase this whole curve over here. We can also have now going 3 standard deviations out. So if this is our mean right in the middle, I'm going to have -1, -2, -3. Again, keep in mind that that's saying our mean minus 3 standard deviations. And I can go the opposite direction too to have mean plus 3 standard deviations. And now we can see that we have even more than before. We actually end up having 99.7% of our data. So in our tails, right, I'm going to use blue here, we can figure out how much is remaining, right? So if we have 99.7% of our data within 3 standard deviations, then that means we're going to have 0.3% remaining. So we'll have 0.3 divided by 2 and 0.3 divided by 2, right? Because those two pieces combined gave us that remaining 0.3% we need to make 100. So we can see now how much is in each individual tail. I want to take this information and work through a couple different examples just to help visualize a little bit more of what's happening, and using some real numbers in here aside from just saying mean or standard deviation. So I'm going to move on to the practice problem number 3. And notice here that we're told adult males have sitting knee heights that are normally distributed with a mean of 21.4 inches and a standard deviation of 1.2 inches. We want to use that rule, the 68, 95, 99, 7 rule, to find the following. So what I'm going to do right away, since I know that all of these problems are using the same data, I'm going to go ahead and sketch this out on a normal distribution. So I have the mean right in the middle, which would be the 21.4. And I want to go ahead and label out to 3 standard deviations in each direction. So notice I'm going to move to the right first. So I'm going to take that 21.4 plus 1 standard deviation, which we're told is 1.2. And so now I have a value of 22.6. And I'm going to keep adding 1.2 each time I go out. Remember, this is plus 1 standard deviation, plus 2, and plus 3. It's a little bit of a sloppy 3. There we go. So I'm going to go ahead and add that standard deviation again to that 22.6, and I end up having 23.8. And then I'm going to add again one more standard deviation to get a value of 25 here. So notice I've only gone to the right side of the mean. We can make sure that our calculations are correct just by going through some of the reasoning here, right? We know that if our mean is 21.4 right in the middle, all the values to the right should be values that are greater than that mean. And we can also make sure that we get those same calculations a couple different ways, right? So what I did first is I added the 1.2 every single time I moved along. You also could have said, I'm going to take, and I'm going to use this one for example. You also could have said, I'm going to take that mean, that 21.4, and I'm going to add 2 times that standard deviation. So there's multiple ways that we can get the values to label our curves. The numbers in the end should all be the same. So whether you're taking 2 times the standard deviation or whether you're adding it each time you go along, whichever way you do it is okay. I'm going to go ahead and label the left side. So all the values on the curve to the left of our mean should be lower than our mean. And remember that we're doing essentially the opposite, right? So now I have the mean minus 1 standard deviation, minus 2 standard deviations, and minus 3 standard deviations. So I'm taking that mean, 21.4, and I'm going to subtract 1.2, and I have a value of 20.2. I'm going to keep subtracting a standard deviation off. So now I should have 19 and then 17.8. And I do have this sketched and labeled on that practice key, so feel free to check that out if this is hard for you to read. And remember that I'm using that curve for all 3 of these since I'm using the same set of information. So now let's go ahead and take a look at it. It says percentage of adult males with sitting knee heights between 19 and 23.8 inches. So I have our curve labeled here, and I can see that 19 is 2 standard deviations to the left, and 23.8 was 2 standard deviations to the right. So I'm asking myself, okay, well, how much of the data lies between or within 2 standard deviations? And we know that that would be 95%. So in that case, we knew that we could use just a value directly from that 68, 95, 99.7 rule. In the next couple of examples, we're going to see ways where we're still using that, but it's not quite as direct. So if we look at B, it says the percentage of adult males with sitting knee heights greater than 19. Okay, so I know, I'm going to sketch it again just to help visualize. I know that 19 inches is 2 standard deviations to the left. So I went ahead and sketched that out. Okay, so now I can't just say it's 95, right? Because I'm only looking at the percentage that is greater than this 19. So notice the difference. On part A, it was within those values exactly. So it was within 2 standard deviation on each side. Here, it's only within 2 standard deviations on the left. So we have to reason through it a little bit. We know that this in the middle, right, this hump or curve right in the middle is our mean. So we know that half of the data lies on each side. So now I have this piece of information accounted for with this 50%, but I need to figure out a way to describe what is between the mean and 2 standard deviations only to the left. So I know if it's 2 within each side, that I had 95%. So if I only want half of that, I'm going to take half of 95. You end up getting 47.5. And that now is added to that 50%, right? So I have this now described as 47.5% of the data. And then the other half of my data, so that 50%. So now I can say the percentage of adult males with sitting knee heights greater than 19 inches is 97.5% of the data. I'm going to go ahead and clear this screen just to move down and do part C and D. So part C says the percentage of adult males with sitting knee heights less than 19. So just a sketch to help visualize again. We knew that 19 was 2 standard deviations to the left. And in that last problem, we calculated that all of the data to the right of 19 was 97.5% of the data. So we know that the entire area under the curve is 100%. And now I'm looking for everything that's left over here. So I know that whatever's over here plus this 97.5 gives me 100%. So I can subtract the 97.5% here to find what's left. So right here is 2.5% of our data. And then to the right of 19 is 97.5% of our data. And we can visualize that from the curve too, right? It does make sense. We have a very, very small piece of our data to the left of 19, and we have most of the data under the curve greater than 19. So these values make sense. Moving on to part D, it says, okay, now let's find the percentage of adult males with sitting knee heights between 19 so this is our mean, and the mean was 21.4. We're looking for between 21.4 and 19. So we worked with this already, right? We said, well, we know that if it was within 2 standard deviations on each side, that we would have 95% of our data. But in this example, we're only looking at the percentage of males that are between those two sitting knee heights. So we're only wanting to consider this half. So that would be that 47.5%. On these examples, I used the value of 19 quite a bit because there is something significant about the values that are outside of 2 standard deviations. So let me go ahead and clear this and move back up to our notes. So whenever we are considering 2 standard deviations, we have our mean in the middle. So again, we have our curve. And we know that within 2 standard deviations in each direction, we had 95% of our data. Well, what we can say then is anything that is more than 2 standard deviations in either direction would be considered to be an unusual value. So it's going to be greater than 2 standard deviations on the right, or less than 2 standard deviations on the left. So if we happen to have a data value that falls exactly 2 standard deviations away, we would still say it's in that 95%. But as soon as it becomes outside of that range in either direction, then we would want to classify that as being an unusual value, because then it's falling within that 5% remaining. And if only 5% of a data value has some characteristic, we would assume in general for that to be unusual. The same with a curve. Okay, so I'm actually going to, just to kind of separate the different topics here, I'm going to stop this video here and then pick up with standard scores and percentiles in the next 2 videos. So the next one will pick up where we left off, and we'll talk about standard scores.